Hello and welcome back to Physical Geology, and today I want to look at the Geologic Structures Lab for this week. In my videos I talk about stress and strain. We did this back when we did plate tectonics, so a little bit of background information. One of the key things for this lab in particular is I want you to understand the difference between this confining pressure and the directed pressure. And we talked a little bit about this when we did metamorphic rocks, and we were calling this differential stress over here. The confining pressure is equal pressure in all directions, right? So a vector shows the general direction and the magnitude or strength of the force. You can see all of these are pretty much the same, so confining pressure equal in all directions. But when you get to directional or directed pressure, we're seeing that the stress is going to be greater in one direction than the other. And so you'll see that we'll have compression, tension, and shear. So these are things we've talked about. Again, if you're looking at the type of strain, remember strain is going to be how the rock behaves to that stress or the behavior, right? So here it is, behavior of rock to stress or that deformation. So usually at shallower levels in the crust, the rock is going to behave in a brittle strain. It's going to deform in fractures, right? So probably faults, reverse faults, normal faults, strike slip faults. Again, we've talked about these already. Or if you're deeper down, you might see some dilation of the rock, which means that it's going to be compressed and then it can be squeezed because of either confining pressure or directed pressure. But then it's going to experience maybe a plastic deformation. And so that plastic deformation is going to lead to folding, right? So geologic folds, right? Or stretching or bending in this case down here. Some important features on geologic maps, the formation. So formation is a unit that you can map at a scale in an area of a 7.5 minute quadrangle. So it would show up on this map. So it has to be large enough to be depicted on one of these maps. And then, so the formations are going to be separated by geologic contacts. And the geologic contacts are either bedding plane contacts, it could be a fault contact, igneous intrusion contacts, or even unconformities. And then again, the geologic map is going to be a flat depiction of Earth's surface with some information not just on structure like strike and dip, the ages of formations and the folds, but also some of these contacts, right? And then the block diagram, earlier we talked about kind of looking at that layer cake model, and it's going to show the geology in the structure section, or the cross section is what your book also calls it to, but it's in the subsurface. So if we can imagine these as being block diagrams, the map would be in the top, and the sides here, that would be the structure section, and that's one of these block models. A big part of this lab is understanding this idea of strike and dip. And so strike is this compass direction, always in reference to north. Here they have a little model showing inclined strata. These would be different geologic formations. Usually this brick pattern's a limestone, the little dashes are shale, and this looks like a sandstone, little sandy grains there. And so these would be the contacts between the different formations. But you can see this whole sequence is tilted off toward this dip direction, right? And so the strike direction is a horizontal line. So here we have the water kind of ponding up against this formation, and that's going to be our horizontal line. So that's our strike line. And then you would measure it in reference to north. So in this case, this looks, if north is going off this way, then this looks like it's north some degrees toward the east, maybe 45, 50 degrees, right? And here they have 65 degrees. So you would measure that with your protractor. That's one of the things you'll need for this lab. You'll need a protractor. Dip is always going to be perpendicular to strike. And it's going to show that direction or inclination from some imaginary horizontal plane down to that geologic surface. So that's the dip angle. So strike and dip. And collectively together, it's referred to as attitude, the attitude of the bed, or the strike and dip of the bed. So, and it's the symbol right here. So it's like kind of like a short T, has a longer strike line, and that strike line is always drawn with correct orientation on the map. So if you put a protractor on this and you would measure this angle back to north, because remember north is always at the top of the map, you can figure out that angle of strike. And so here's some kind of examples where we're looking at the strike and dip of inclined strata, the strike and dip of horizontal strata, and the strike and dip of vertical strata. We'll have more on that in a moment. When we're looking at this lawn chair, right, or this deck chair, where you're sitting would be horizontal, but the back has a strike and a dip because it's inclined. And then here we have some water up against this rock surface, so that water makes an imaginary line of strike, like in this figure up here. And remember, dip is always perpendicular to that, right? And then here we drop some water and we see that the water is moving in this direction. So remember, if we can figure out the dip direction, because remember dip is an inclination here, perpendicular to that would be our strike. Dip is perpendicular to strike. So here's some little ideas to try to figure out strike and dip. So what I want you to do on this section here, and we'll look at the document camera here. So you're going to use a protractor to measure the orientation or the strike and dip of these two little strike and dip symbols that I have drawn here on page 140. And so for starters, use your ruler to make a longer north arrow, because remember the north is always at the top of the map. So this is the top. North is up at the top, south is on the bottom, and then we'd have east on this side and west on the other side. So I'm going to draw a vertical line here to show my north line. So that's my north direction is going off in that direction. So I want to measure, if I kind of extend this line out here, I want to measure that angle there. And so when I put my protractor there with a bullseye at that angle, I see that this is going straight to 90, and then this is going off to about maybe 50 degrees here. But remember, I want this angle here, so I want to count back from 90. So I go 90, so I go 10, 20, 30, 40 degrees, right? So from 90 to 50 is 40 degrees. So this is striking north, 40 west. Remember, west is on this side. So you would say north, 40 degrees west. And so by convention, we always draw north first for the strike, then either the angle from north, and then whether you're east or west of north. So that's the convention we use for drawing strike lines. So for dip, the dip direction, we normally just record the dip direction. So note that the dip is going off in this direction here. So that direction would be to the southwest. And here they tell us that it's inclined 24 degrees to the southwest. So you'd write those 24 degrees in as well. Remember, a geologic map is a flat surface, so we really can't show the 24 degrees other than just saying 24 degrees on the map. So that's telling us that the strata here is inclined 24 degrees in that southwest direction. All right, so I'll leave you to do problem 2. On page 141, there's some important symbols we use for geologic maps. Strike and dip symbols. We talked about the vertical strata, the horizontal strata. These are a little bit more complicated, where you have geologic folds that are overturned. But the more important ones I want you to know for the folds are these. So this line here represents the axial plane of a fold. In this case, it's a syncline because the two arrows are pointing toward the center. That means that the strata are all dipping toward the axial plane, syncline. And then here we have the axial plane for an anticline, and note that the strata are dipping away from the axial plane. And then when you have a plunging fold, and we'll look at some of these later, this arrow indicates the direction of plunge, either for an anticline or for a syncline. And then we also, we talked about reverse faults here. We usually use this for a normal fault here, the up and down. And then here is the line for contacts. Those are the main ones we want to know out of this figure here. Don't worry about the other ones too much right now. And then also we use symbols to designate the geologic periods. So D for Devonian, S for Silurian, O for Ordovician, C Cambrian here with a little line through it, because we use C for Carboniferous, right? And so we use K for Cretaceous. So kind of go back and look at this here. Just keep this in mind here on page 141. All right, so the next part here, we want to do this little cross section on the map. So let's go back to the document camera. So on this figure here, we're going to construct a cross section, and we'll be doing a lot more of these when we look at the block model. So this is kind of like looking at just one face of the block model. Remember, the block model is going to have 1, 2, 3, 4 faces, right? So here we have on this little inset map that I have here, I have a general topographic map with some strike and dip symbols. So it looks like that these strata are striking north-south, but dipping toward the west. This one is also striking north-south, but dipping toward the east. And these are strike north-south, dipping back toward the west. And you can see the little strike and dip symbols here. As you can see that this is depicting some sort of subsurface geology in the cross section as an anticline and a syncline there. And so on our diagram, what we want to do is we want to kind of approximate as best we can that angle of dip. So whenever a geologic contact crosses the line of section, this A to A prime that we want to show the structure on, we want to record where that contact is. And also note that there must be a stream that moves through here because there's a little V here. Remember, the rule of V for geologic contacts tells us that the V points in the dip direction. So these strata seem to be dipping off toward the west. And you can see that they actually do have a strike and dip symbol here. It's dipping 45 degrees off to the west. So to do that, you would want to place your protractor here and incline it at 45 degrees. So 45 degrees would be right around. So the way I'm doing it here, I'm looking at the bullseye here and I'm imagining a horizontal line going right through that 45 right there. So there's 40, 45. And then once I establish that, I'm going to move this up a little bit so I can draw that 45 degree angle right here. So that strata is dipping off in that direction at about 45 degrees. And then over here, this is also doing the same thing at about 45 degrees. All right, and then I don't know what's going on here because I don't see strike and dip data, but I'm going to plot these over here. And so I see that these are dipping 45 degrees off toward the east. So I'm going to do that same 45 degrees here and plot these in here. There we go. Which tells me that this unit here must also be plotting back down here at 45 degrees. So I'm trying to keep a uniform thickness here, and I'm going to plot these in here as well. So it looks like it's some sort of anticline that kind of goes up here, kind of curve. If I can show this geology up, above the surface, it would show this kind of anticlinal geology. So that's an anticline with an axial plane going through the middle. One thing that I always emphasize is coloring both the geologic maps and your structure sections. And when you color them, you can really see what the geology is doing. So we do see an anticline here. So I've kind of matched the colors. I didn't quite have this color here, but I made it kind of an orange color. And then right through the middle here, we would see our axial plane. So I'll put the AP for axial plane right there. And that axial plane would go right through the middle here. And since it is an anticline, we would use the symbol for an anticline, this one here, and we would show the two arrows pointing away. So what I want to see on your sheet, I want to see this structure, an anticline. Color it, right? So you want to make sure you color. You want to make sure you show the axial plane, right? And then that'll complete this part of the assignment. All right, so page 142 is just a little bit of background information. The key thing about this one is looking at these diagrams for tensional stress, compression, and shear stress. And then there's some ideas of this brittle failure, right? So remember, brittle deformation is happening usually at shallower levels where the rocks is still cool and it's going to break or fracture. So there's some different types of faults here: normal faults, reverse faults, thrust faults, which are a special type of reverse fault, and then the strike slip faults here.